According to dictionary.com, continuity is defined as the state or quality of being continuous, a continuous or connected whole. What does it mean for a function to be continuous? In what ways can a function be discontinuous? We will explore the answers to these questions and the meaning of removable and non-removable discontinuity. The flow of water in this creek has been stopped by beavers who built a dam. We could say that the water's flow is discontinuous. However, by removing the beaver's dam, the water would again have a continuous flow, and the discontinuity would be removed. This type of discontinuity is called removable. This car was driving along a continuous road when they came upon what appeared to be a puddle. As they began to drive through the puddle, they soon realized that it was an enormous pothole. This is another example of removable discontinuity. The discontinuity of the pothole can be removed by simply filling in the pothole with an awful lot of dirt and covering the dirt with asphalt. The car's path will then be continuous. This discontinuity is removable because the hole can be filled. F of x is a discontinuous function at x equal -2 because of a hole. But like the pothole, this discontinuity can be removed by creating a piecewise function. Notice the hole occurs at -2, 1. This piecewise function removes the hole at -2, 1. By using f of x and making its domain every number but -2, we can define a new function y equals 1 whose domain is only -2. Thus the second function is the point -2, 1 and essentially fills in the hole. If these people continue walking, they will walk off the cliff and fall into the water below. The cliff is an example of a discontinuity that is called a jump. This man continued walking towards the cliff and, as you can see, is falling. Once he hits the water, he could continue his journey by swimming. This type of discontinuity is non-removable. There is nothing that can easily be done to lower the cliff or raise the water so that the man's path would be unbroken. This is an example of another type of discontinuity called a gap. If you were on one side of the canyon and walked towards the other side, you would never make it because of the large gap. This is another example of non-removable discontinuity because it is not a simple feat to bridge the gap. This is an example of a function that is discontinuous at x equal -1.12 because of a large jumper gap. This discontinuity is non-removable. Humor me and imagine that the creek and road go on infinitely as they appear. If you are on the road, you would have to leave the road to get to the creek. Similarly, if you were in the creek, you would have to leave the creek to reach the road. For our purposes, the land between the road and the water is like an asymptote on a graph. The water and road would never meet, so the graph would always be discontinuous. This is another example of non-removable discontinuity. These railroad tracks are another example of discontinuity caused by an asymptote. Imagine these tracks continue infinitely. You would have to leave one track to get to the other. Discontinuities caused by asymptotes are non-removable because there's no easy way to plug the gap. This is an example of a function with a vertical asymptote. Since neither side of the graph will ever touch the other side, there will always be a gap, so the function will always be discontinuous at x equal 1. This is an example of non-removable discontinuity. If you can trace a function without ever lifting your pencil, like tracing one of the yellow lines on the street, the function is continuous. A function can be discontinuous in several ways. A hole causes a discontinuity which can be filled, so this is referred to as removable. A jump, gap, or break in a function, like the white lines on the street, are too large to fix, so these discontinuities are referred to as non-removable. And so begins our study of continuity.